Testing, testing, 1, 2, 3. Okay, let's have a look at homework 10, which is due on Wednesday. Now, as I mentioned in class, the first question you can do without assuming anything. You don't have to use reductio ad absurdum, you don't have to use conditional proof. What we said in class still holds. If we're doing the method of working backwards from the conclusion, we notice that the conclusion is E, and the only premise that it shows up in is premise 4. So if we were to get E out of premise 4, it would be by disjunctive syllogism, because this is a disjunction, and we want to get one of them. So what we need is to get a negation of the other one. So you think to yourself, you make a little note to yourself on scrap paper, I want to get this. And then you think to yourself, well, how can I get that? Well, remember that this is equivalent to not A and not D by De Morgan's law. So if you can get not A, and you can on another line get not D, then you can do conjunction, join them together, and then do De Morgan's law, which of course works in both directions. So normally we start with this and we go here by De Morgan's law, but we can also do it the opposite way. We can create this and move to this, and then we can use that to get E. So you think to yourself, all right, now my new target is to get not A and also to get not D. Well, you can get not A out of this once you have done something to this one, something involving a person's name that we've just mentioned. Now you also need to get not D. Well, you're going to be able to do that using the other side of this when you've done De Morgan's law to it, and you have to do bicon to that one. Somebody in class did it and said it took about till line 14. That sounds about right. Okay, so that's the first proof. No assumptions necessary. In theory, it's possible to do this one without assuming anything too. But if you did that, you would do a fair number of hypothetical syllogisms. Why? Well, look that the conclusion is a conditional. And we know hypothetical syllogisms which look like basically, P then A then Z, and then you do hypothetical syllogism, you would get if P then Z, like that. That would be a hypothetical syllogism. Well, here you have the thing where P is the antecedent, like this, and here you have the thing where Z is the consequent, like this. You just have to make these match up, and that's going to require involving all of the lines. Now, that's one way to do it. Probably an easier way to do it is to do conditional proof. Now, if you remember, conditional proof is a way of proving a conditional like this, and it works by, you start by assuming the antecedent of the conditional you want to prove, which in this case is P. And then you keep going until you get your, and remember you're in fantasy land here, that's why they're indented, and you keep going, say, to line 99 when you end up with Z. However you got that. Actually, it's probably by modus ponens, given that it's the consequent there. So let's say modus ponens, whatever lines. Well, one of them lines is, it would be 4, 98 probably. And then when you got that, line 100 is you proved if first indented line, then last indented line, by conditional proof, all the indented lines, 5 through 99. Now, obviously, it's not going to take 100 lines. I'm just trying to scare you. But another thing you're going to have to do is you're going to have to do a lot of rules of equivalence, because when you get P, the first thing you can use it for is modus ponens, which is going to give you this. Now, how is that going to help you? It's going to help you with this, but you have to do a couple of things first. I think I've said enough on that one. Okay, let's look at number 3. Now number 3, of course, you can't do conditional proof because this isn't a conditional. But for number 3, I recommend reductio ad absurdum. Now if you remember, yes, that's my cat. Say hello, Martha. There you go. Alright. With reductio ad absurdum, what you do, remember, is you assume the negation of whatever it is you're trying to prove. So you're trying to prove U, so you would assume not U by assumption reductio ad absurdum. Now, that's how you start a reductio ad absurdum, and remember, you keep going until you've got a contradiction. What contradiction? Could be anything. Could be P and not P. Could be Q and not Q. Could be R and not R. It could be Q or S and not Q or S. Anything. Whatever you can come up with will work. But the first thing you're going to do is you're going to use that not U with line 2, and you can also use it with line 3 using modus tollens. And then when you've done that, you will follow that up quickly with using De Morgan's law, if you do your modus tollens right. One thing to look out for is, in case you're thinking, oh look, 2 conditionals, I can do a dilemma, like a constructive dilemma or a destructive dilemma. No, you can't, because that's a disjunction. To do a dilemma, that would have to be a conjunction, so you can't do that. With that in mind, you might think, oh, well, at least I can do a dilemma with this one, because that is a conjunction. And in theory, you could. It's just that you won't be doing that in this case. I'll tell you that for nothing. So I've told you everything I'm going to tell you about this one. A good method is to start by assuming not U and then try and get a contradiction. And suppose you get that contradiction on line 99, then on line 100 you will have proved U by reductio ad absurdum 5 through 99. That's how that one will go. This one, well, obviously you can't do conditional proof because this isn't a conditional. And I wouldn't start off by doing reductio ad absurdum. Maybe if you get stuck, you can do reductio ad absurdum. But just do as much as you can to begin with. And maybe you'll never need to assume. And I recommend starting off by doing simplification both sides to this one. So that'll be line 5 will be simp 2, and line 6 will also be simp 2 the other side. And then do simplification on line 4 twice. And you will notice this matches this, and this matches this. And you're able to, and you should be off and running. Another point to make is that if you have S, which you will get very quickly, you can get S or W by addition. That's a big clue. The other thing to notice is that supposing you wanted to do modus tollens with that, what would you need? You would need not Q or R, because modus tollens is denying the consequent. Well, think about what this is equivalent to. And we've actually talked about something very similar on the first proof. So if you wanted to get that, how could you get it? Well, the same way I recommended that you get this in proof number 1. Alright, those are some hints. I hope that helps you. Do as much as you can before Wednesday. Go to see Eric the tutor. We will be able to do a little bit of work in class, but don't count on doing all of them because we won't have time for that.